we are gonna see the chapter motion in a straight line. Okay. Uh, it may have some three parts, 3 or 4 parts. In this session, we will see the introductory concepts related to motion in a straight line. Okay. After these sessions, you will be clear about the concepts which will help you in solving problems and all. Okay. So let's go to the topic motion in a straight line. Okay. This is the chapter. What is meant by motion? Motion means, suppose there is a ball here. Okay. In your room, there is a ball. Okay. You saw this ball at this moment. Let this moment be t is equal to 0. Okay. That means right now you just saw. And after some minutes, say after some 5 minutes, you saw the same ball lying here. Okay. That means the ball got moved, or the ball's position got changed. Okay. From here, its position got changed. So motion is nothing but the change in position with time. Okay. One moment a body might be here. Okay. The next moment the body is here. That means its position has changed. Initially the position was here. Position we always refer using a frame of reference. Okay. Like x and y axis. Suppose this is y, this is x. Okay. Initially the body was here, now the body is here. Initially the body was here, now the body is here. And this reference, this axis could be moved. Say maybe the axis could be right here. Okay. So basically motion means the change in position. Suppose a bag was here. Okay. And the bag was kept in a escalator. In airports you can see escalators, right? In that escalator it was placed. After some time the same bag is at this position. Okay. So the change in position, this change in position of a body, of an object with respect to time, is called motion. Okay. And motion, if you take motion, you can see the motion could be of different styles. Say the motion could be from here, the body was here. Let me represent bodies using a dot. Okay. The body was here. After some time the body came here, and it came like this. Maybe this was a football, somebody kicked it, it reached here. Okay. So this is a motion. Okay. The path of motion is this one. Okay. So likewise motion could be of different types. It could go like this, it could go like this, it could go simply like a wave. There are n number of motions available, n number of types of motions available. Here in this chapter we are going to study about motions in straight line. Okay. We are not bothered about, say, circular motion. There is circular motion, there is a wave like motion, there is angular motion, etc. We are not worried about those things. We are going to study only one type of motion, that is a straight line motion from here to here. Okay. A body was here and came here in a straight line. So in this chapter what we are going to study is the change in position of a body with time along a straight line. Okay. Like this, like this, like this. So This is what we are going to study. This is, you can see, this is relatively an easier version of motion, right? Say when you drive a car, it's quite easy to drive in a straight line. Okay, in a straight highway, it's very easy to drive. Similarly, studying motion in a straight line is quite easy. Okay, so don't get worried, it's quite easy. We'll make it, it will finally at the end of the chapter you will understand. Okay, so let's start. So in order to, I told you what is motion. Motion is a change of position with time. Okay, so first we will see what is position. Position is nothing but, suppose a body is here. Okay, and we have the references x and y. Okay, this is x, this is y. This point has got a coordinate with respect to the reference x comma y. Okay, this is called its position in a 2D. In 2D, I'm saying, if it was 3-dimensional thing, it would have been x y z. Okay, in a 2-dimensional motion, it could be only x y. If it is a 1-dimensional motion, say if it is moving only along one line, okay, then it could be just, the whole position could be referenced only using a single parameter, say x. Maybe the motion could be just like this. Okay, then it could be referenced, it could be explained using just y. Okay, but here we are, let's see a particle, let's see a body here. Okay, it's in a 2-dimensional plane. Its position could be marked as, say, x1 y1. Okay, and after some time it reached here, which is x2 y2. So position is nothing but the distance, the coordinates, distance or the coordinates of the body from a reference. Okay, here the reference is this, the origin of this graph. Okay, so this one is r1 vector, this one could be r2 vector. Don't mind this, just I am telling you. Okay, you just need to have an understanding of what positions are. Position is nothing but pinpointing the coordinates of a body on a plane, on a space. Okay, on a plane if it is a 2D, on a space if it is a 3D, on a line if it is a 1D. Okay, so that's about position. I hope that's clear. Okay, for example, for a better understanding, let me place a frame of reference. Let me place x axis, y axis. Okay, and let me divide the axis. Each is 1 centimeter. Okay, each division is 1 centimeter. Okay, and suppose I am placing a football at this point. I placed a ball at this point. Okay, what is the position of this body, this ball? Let's see. The x-axis, you can see it comes here, right? That means 1, 2, 3, 4. It's 4 centimeters. So 4, comma. What about y-axis? Y-axis, it coincides like this, right? 1, 2, 3. So y-axis is 3. So this is the position of that body. Hope it is clear. Okay, so now let's see displacement of a body. Okay, so again let's take a plane. Okay, x, y, and we have a body here. Okay, We are going to study displacement and distance. This both we will see. Okay. Let the body be here initially. Okay. Let this be point 1. And after some time, it reached here, point 2. After some time, it reached here, point 3. After some time, it reached here, point 4. After some time, it reached here, point 5. Okay. And its path, how it moved is like, suppose it moved in straight line from here 1 to 2, a straight line, 2 to 3, another straight line, 3 to 4, another straight line. Okay. Then 4 to 5, another straight line. Okay. This is how it moved. Now I am asking you, what is the total distance traveled by the body? What is the distance traveled by the object? Let distance travel will be, what will be distance traveled? The total length of this white line, right? 1 to 2 plus 2 to 3. Suppose this is 3 centimeter. This is 2 centimeter. This is 2 centimeter. This again is 3 centimeter, say. So what is the total distance traveled? 3 plus 2 plus 2 plus 3. 3 plus 2 plus 2 plus 3. That is 10 centimeter is the total distance traveled. Okay. It traveled like this. But I am asking you, what is the total displacement here? So distance traveled is nothing but the total movement of the body. The total movement happened to the body within a given time. Okay. While I was observing, the body moved from point 1 to point 5. Through which path? Through the path 1, 2, 3, 4, 5. So the distance traveled depends on the path. Okay. Distance traveled depends on the path. For example, suppose the same body moved from 1 to 5 in a different path. Okay. The red color path. But still the starting and end are same. Okay. 1, 2, 3, 4, 5. Okay. Here the path is, which is the path? Path is the red color. The path is red color, right? In that path, the distance might be, this might be say 4, this might be say 3, this might be 3, this might be 4. Then the distance traveled in this case, the previous one was D1, this one is D2. Here the distance traveled will be 4 plus 3 plus 3 plus 4. So 4 plus 3 plus 3 plus 4. That means 7 plus 3, 10, 10 plus 4, 14 centimeters. Even though they moved from the same point. Okay. It's like, say, he started from, these two are two guys. The white line, the same guys, but the first guy traveled in white path. Okay. Suppose you take two guys in your classroom, in your two among your friends. Okay, they both started from the same points and they both finished at the same points. But who traveled more distance? The red color guy traveled more distance. Okay, so that is about distance. Distance is dependent on the path taken. Okay, and it's not a vector quantity, it's a scalar quantity. It doesn't have any direction. Distance doesn't mention you 10 centimeter means 10 centimeter. It's just a magnitude. It doesn't tell you in which direction this has happened. 14 centimeter, but it doesn't tell you what is the direction of that motion. Okay. Here comes the next one, displacement. Okay. displacement. Displacement is a vector quantity. Displacement means the shortest distance between 2 points. Okay, while distance is what was the distance between 2 points? Distance between the 2 points 1 and 5 is the total motion happened in between 1 and 2. Okay, at the same time, displacement is the shortest distance between 2 points. Let's again come back to the same case. Okay, as the body moved from 1 to 5, okay, as the body moved from 1 to 5, I am asking you, what is the displacement happened? Displacement happened is, what is the definition? It is the shortest distance between 2 points. Okay, so from here, from 1 to 5, what is the shortest distance? It will be a straight line being drawn from 1 to 5, right? If you have 2 points, there could be n number of n number of paths connecting 2 points, right? Of that, who will be the shortest? The one which is a straight line connecting 2 points will be the shortest. So that line represents the displacement. Okay, so here this green line is a straight line, that is the shortest distance connecting 1 and 5. So this must be the displacement. This might be, say, 3 centimeters. Okay, so say if this is 3 centimeter, then displacement between 1 and 5 is 3 centimeters. Okay, then let me ask you another question. Then what about the displacement for these two guys, that white colored guy and red colored guy, one in white dress and one in red dress? We already saw that they had different distances. The white had 10 centimeter, the red color had 14 centimeter. So what about displacement for the two guys? Yeah, it has to be the same, because so what about the displacement for the two guys? It has to be the same. It must be 3 centimeter for both, because displacement is not path dependent. Okay, it's not path dependent. It depends only on the initial point and final point. If this is the initial point and this is the final point, then the displacement will be the straight line connecting these two. And it is a vector quantity. Vector quantity means it has direction. The direction will be always from the first point to the second point. Okay, it's a straight line, right? The straight line can have two arrows. You can put two arrows, two directions, from 1 to 2. Out of that, in the case of displacement, the arrow must be from the initial point to the final point. So, okay, so it must be like this. Suppose the initial point is here. He traveled and finally came back to the same initial point. Then what is the displacement? 1 and 2 happens to be the same points. Then what is the displacement? Displacement must be 0 then. But the distance will not be 0. Distance is the total length of the path. Okay, so the difference between displacement and distance is distance, displacement. Okay, let's see. What about distance? Distance is a scalar quantity. What about displacement? Displacement is a vector quantity. Distance depends on path. Okay, it is independent of path. Okay, and you can see the displacement will be always lesser or equal to, at the max it can be equal to distance. Okay, it will always be, it will, displacement will always be less than or equal to distance. Why it is so? Because displacement is always the shortest distance between the 2 points. And when they will be equal, when they will be equal when, say, suppose point 1 is here, point 2 is here, okay, and it moved in a straight line like this, okay, this is a straight line. Here, what is the displaced distance traveled? It is this length, right? This length, okay, distance is this length. What about displacement? Displacement will be also the same magnitude, but it has got a direction from 1 to 2. So, and 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 that's the main difference between distance and displacement. um, One is path dependent, one is independent of path, one is scalar, one is vector, and the displacement will always be less than or equal to distance. So that's a basic understanding of distance and displacement. Okay, so we will continue with the continue this we'll continue the same topic in the next session. Thank you.